I will share the screen. Okay. So we have seen various steel structures. We have also seen the shapes, the types, classifications, and slowly we have dealt with the uh, shape factor and load factor concept. So this was discussed in the previous lecture. We also came to know what is this MP value, that is the plastic moment, which is essential to calculate these shape factors as well as the load factor values. And now what we will do is we will shift our gears to this part, which is known as connections. So fine. Why the connections are to be provided? First of all, we should understand this concept, that why there is a need to provide any type of connection in steel structure. So the answer probably perhaps I have jotted down. It may form that the steel structural members used in structures have to span great lengths and enclose large three-dimensional spaces. So if you remember, we had discussed the common thing which was observed in the pictures which I had shown to you, wherein one of the students rightly told me that steel structures are provided at the place where the area requirement is more, isn't it? So, in order to provide or suffice that area, the steel structure members should be such that they should cover the great lengths, or the area covered by them should be more, and because of which the connections are necessary to synthesize such spatial structures from one and two dimensional elements, and also to bring stability of the structures under different loads. So this is the purpose of connections, that it should synthesize the three-dimensional structures um, from one and two dimensional elements, and also to bring about stability of the structures under different types of loading conditions. Okay, so this is the necessity. Uh, but since it is a concept, so few limitations can be seen. What are those? Any joint in a structure is a weak point or location, and this is very important point. Remember, the force which will be attracted if for a given structure, if it is subjected to certain amount of load or force, you can say, the first point at which the force will be attracted, it will be nothing but the weak point, and that weak point is nothing but the connection. Slowly you will understand how these connections are prepared, and based on that understanding you will come to know that the connection forms a weak portion or weak joint. Okay, so since it is a joint, any joint in a structure is weak. It is a weak point. Okay. Secondly, usually connection failure is not ductile as that of the steel member failure. Try to understand this point. Okay, just keep this statement in mind. What it says, usually connection failure is not as ductile as that of steel member failure. Uh, to summarize this, I will just tell you one thing, that this joint or this connection, this is very small compared to the overall length of the other members which are getting connected with each other. For example, if you are connecting a beam and a column, lengths of the beam and the columns, they are quite more compared to the this connection. Okay, the point at which these two things are getting connected, we will call it as the point joint. Okay, so that joint, you will find at that joint, whatever connections are done, with the help of different methods, those joints are very small compared to the overall length, and because of which, uh, since length parameter will come into picture, ductility obviously it will be more, right? Then, to achieve an economical design, usually it is important that the connections develop the full strength of the members, right? So we will see this last point when we will be solving few numerical. In that case, we will understand that what is the importance of this statement, that usually it is important that connections develop full strength of the members. Okay, so this is a requirement actually, and how it can be achieved, that we will see. So these are few challenges, or what we can say, these are few limitations as far as connections are concerned. So we have understood why the connections are required and what are the limitations, and based on these limitations, how the design can be done. That is what we will have to see, right? So what are the different types of connections? Those are used very frequently used. First is the bolted connection, second is welded, third is moment resisting, and fourth, this is riveted connection. And this riveted connection nowadays, they are not carried out. Okay? Even in your syllabus, you will find that riveted connections uh, details or design that has been eliminated. So you will understand the bolted and welded connection in BE syllabus. In elective or in MTech, you will find the concept of moment resisting type of connections. Okay. So firstly, we will see what are bolted, welded, moment resisting, and I mean the types. So can you see this figure one? In this figure one, you can see the column and the beams. They are getting connected at this junction, which we call it as a joint, as already discussed. Now this junction is made powerful, or it is given a kind of strength in order to take care of the moments which will be developed, the forces, shear forces, moments, whatever moments or shear forces those will be developed, those will be taken care by these types of connections in order to make this joint strong. That is, the capacity is increased. Now, what are these? These uh, typically they are known as bolts. Okay, so these bolted connections can be seen in picture one. Over here you can see there are various components which I will be describing later on for the bolts. Okay, so this is a bolted connection. This is second one. This is weld connection. This is a smooth connection, and you can see that two different members. Let's say this horizontal member, this diagonal member, they are more or less monolithic kind of thing, in the sense they are connected by the virtue of this weld, isn't it? So this is a welding connection or welded connection. Okay. Next is moment resisting connection. So moment resisting connection not necessarily is made up of only bolted connection. यहाँ पे जो मैंने picture दिखाया, this is picture number 3. Moment resisting connections are those connections which will resist the moment. Major value will be governed by the moment, and the secondary value is of shear. So you will find in such connections, in mostly the frame connections, you will find that the moment is predominant, and that moment at the joint or at the ends, that is at these locations, they are to be resisted. So such kind of connections, they are known as moment resisting connections. That those moment resisting connections may be of bolts or weld or combination of bolting and welding, both can be done depending upon the magnitude of the moment and other force which is there at that joint. Okay, so that design is typical design that you will be studying in elective course or in the MTech course. And lastly, the riveted connection. So these are the old connections which you must have seen on the railway bridges or so, right? So these connections were provided usually initially. Now they are obsolete. Now nobody uses riveted connections for connecting any main members. I am saying I am talking this in terms of the main structures like the residential, industrial, or the commercial complex, or even bridges, etc. Right? They have been because they owe different types of advantages. Mostly the fatigue part. The fatigue cannot be taken care as well as the bolted or welded connections. Okay, in case of riveted connection. So right. So this is the general summary that the different types of connections which I have told you. Now slowly we will consider the first connection type, that is the bolted connection. So the bolts are of different types. First type is unfinished, or it is also known as black or C grade, which conforms the IS 1363 2002 code. It is used for light structures under static loads such as small trusses, purlins, bracings, platforms, etc. It is made up of mild steel with square or hexagonal head and nuts. So this is a general identification. How to identify black bolts? They are usually known as black bolts instead of unfinished or C grade. And how to identify them? Uh, Firstly, they are made up of mild steel with the square or hexagonal head and nuts. So I will let you know what is this head and nuts. Then second is turned. This is known as turned bolt, used in special jobs in machine and where there are dynamic loads. So you will find that these turn bolts, which are again made up of mild steel only, actually they are widely used for various types of jobs. Like you can consider the different types of structures to be made up of turn bolts only. Okay. Then second is the as per precision or A grade, which conforms to the IS. What happened? One minute. What happened? Wait. Yeah. So A grade type of bolt, which conforms IS 1364 2002. Then there are semi-precision B grade type. Okay. IS, it conforms to IS 3640 and 1364 2002. Then there are ribbed type of bolts which are used rarely in ordinary steel structures. Then uh, these are very good type of bolts which are known as high strength bolts. The advantages of high strength bolts are they don't allow any slip between providing rigid connections or provided rigid connections. They are slip resistant. Okay. Then the load is transferred by friction only. There is no shearing and bearing. Okay. So you must be aware of this term shear. Okay. Are you aware of this term bearing?
Yes.
See, bearing is nothing but when two rigid bodies when they come in contact with each other and they try to exert their forces depending on their material properties. That phenomena is known as bearing. Got it? So load is transferred by friction only. Shear, you know. Bearing, I have told you. So these two concepts are not considered in case of high strength bolts. Then smaller size of overall connections can be obtained with the help of such type of bolts. देखो इसका मीनिंग क्या है स्मॉलर साइज ऑफ ओवरऑल कनेक्शंस. So as you can see over here in this picture, the number of bolts which are provided, those are based on the design. These are, you can consider, turned bolts, and the number of turned bolts based on the design is obtained these many. But in case of these turned bolts, if the designer choose to consider the high strength bolts, in that case you will observe that number of bolts will reduce because of the property, because of this property that load is transferred by friction. And then what are the different, ultimate load which that high strength bolt may carry. Depending on those values, the overall design, it will get revamped, and based on that revamp you will see the number of bolts they reduce. But even the number of bolts they are reduced, the strength will not vary. So that is the beauty of high strength bolts. Then noiseless fabrication. See, all these things, steel structure construction, first of all, it is very fast. It will be fast provided this workmanship is up to the mark. That means skilled workmanship is required in order to construct any steel structure. Okay? So this is the prerequisite you can consider. Okay, and based on that, the noiseless fabrication can be easily achieved. Understood? So these are the types of bolted connections which I have told. Out of that, we will be concentrating more on the black or the turned type of bolts. And now you can see here, this is the picture of the bolt. So are you able to see this figure clearly? And
Yes.
are you able to read the different these things, the description written? So now see, this is known as the head of the bolt. This portion is the radius. This is known as the shank. So shank is the smooth part of the bolt, which is in the vertical direction. This one. This is also known as the grip length. Okay. This is known as the nut. This is the nut part. This is this ribbed portion is known as thread, and the length of the thread is known as the thread length. And from here, that is up to the end of the bolt to this point, is known as nominal length of the bolt. This is typical bolt which you will come across in any connection, in any structural steel connection. Okay? These are very common nuts which you have used in your day-to-day life. I hope so. For small fixtures or something like that. Even doors or some furniture fixtures, you make use of such type of, these are, you can say, black bolts. Okay? So there is one more term which is not introduced over here, that is this small thin plate. This is known as washer, WASHER, washer. Okay, यहाँ पे भी आप देख सकते हो, this is a washer. So this is a you can say turn bolt, which normally is made use of. Okay, so these are various components of bolt, and you can see the head of this bolt is hexagonal in shape, right? So typical hexagonal shape can be observed for nut also. Then for threaded portion, you will see there are different parameters which are defined. Like this is the outer to outer distance is known as the major diameter. Then this is the minor diameter, so minimum diameter, inner to inner. And then this is known as the pitch diameter. What is pitch? Pitch is nothing but distance between these two threads. Okay, and the this uh, intersection, you can say, this is known as root. This is known as crest. And this angle which the thread makes, this is known as the thread angle. Right? So these are the different components of any bolt. Now, the most important thing which we need to consider is the mechanical and physical property of the bolt. Screws and studs, those are the same thing. Only the usage point of view, the terminology will change. Now, see, what are the mechanical and physical properties? Can you see this property class? This is 3.6, 4.6, 4.8, 5.6, so on. So these are nothing but the grades of the bolt. If you remember, I had told you about the grade of the steel. What are generally the grades of the steel? How they are expressed? Do you remember any one grade? How it is expressed? So I will go back to this slide. See, this is the grade classification. What it says? FE410WA, and I hope I had described each and every component of this. FE stands for the engineering, iron or steel. E stands for engineering steel. W stands for the whether the steel is weldable or not. And A, B, and C, these are the different grades based on different situations, right? So accordingly, the bolts are provided with different types of grades like 3.6, 4.6, 4.8, etc. So if I say 4.6 grade is given to you, the grade of the bolt is, let's say, 4.6. So what is the meaning of this, physical meaning of 4 and 6 in case of the grade 4.6? 4 is nothing but 1/100th of the ultimate tensile strength, which is given in MPa. Meaning is 4 divided by 400 divided by 100 is that value. Okay, that means that for 4.6 grade, the ultimate tensile strength which is calculated for that bolt, whose grade is 4.6, the ultimate tensile strength value is 400 MPa. That is the meaning. And what about this 0.6, or rather 6? 6 is nothing but the ratio of the yield strength to ultimate strength. Ultimate strength तो हमको पता है, that is 400 MPa. What should now be the yield strength as per this? If it is 6 value, what should be the value of yield strength? Will it be 240? Will it be 240? यानी अगर मैं 0.6 कंसिडर करता हूँ, तो what it should be?
Yes, sir.
है ना? 240 MPa. So that is the physical meaning. Similarly, if I consider 4.8 grade, in that case, what should be the value of ultimate strength? Sorry, yield strength. Yield strength, not ultimate strength. It will be 32, 320, 320 Newton, 320 MPa, isn't it? So you can see over here for 4.8, lower yield stress value, nominal and minimum, you can check the nominal value to be 320 MPa. Similarly, for 4.6, it is given as 240. For 5.6, it will be 300. For 5.8, it will be 400 and so on. Okay? So this is the meaning of that. Because we will be making use of these values of yield strength and the ultimate strength in our numerical. So that's why this physical properties are to be understood. Okay? Is this okay?
Yes, good.
Fine. So next type is the black bolt. It is unfinished and are made up of mild steel and are usually of grade 4.6. Beyond that, the black bolts are not provided. Have adequate strength and ductility when used properly, but while tightening, the nuts snug tight. Snug tight का meaning क्या होता है कि the tightness that exists when all the plies in joint are in firm contact. Okay, when you tight the nut, one stage will exist wherein all the nuts, whatever number of nuts you are providing in one connection, they are tightened enough, which is known as the snug tight condition. And if the nut snug tight will twist off easily if they are tightened too much. So that is a disadvantage of the black bolt. Okay, so even if with further increase in the loading in order to tighten the complete connection, then there is a warning that it will twist off, and there is also chance of failure. So this is a disadvantage of black bolt. Whereas in case of turn type of bolts, they are available in grades of 4.6 to 8.8. So you can get variation as far as turn bolts are concerned, and the grades which we can make use of, they vary from 4.6 to 8.8. They have uniform shanks and are inserted in close tolerance drilled holes and made snug tight by box spanners. So there are different techniques in order to tighten these types of turn bolts. Then the diameter of the hole is about 1.5 to 2 mm larger than the bolt diameter for ease in fitting. So most of you must have this question that how to uh, make use of these bolts in any connection. This must be the case. So just remember one thing, that for any connection, if we say that there is one plate like this, and this plate is supposed to be connected with another plate, let's say this is the second plate, and if I want to connect this with the help of bolt, so what is done? Holes are drilled. First of all, these holes are drilled into these plates where the connections are to be made. Later on, the bolts are inserted, and while doing so, one thing is to be taken care of. The diameter of this bolt holes should be more than the diameter of the bolt, and usually it is around 2 mm, 2 mm more than the diameter of the bolt. Okay? So this is how the bolts are they can be easily inserted into the hole which has been made in these two plates or whatever the connection may be. So in that hole, the bolt is inserted, and then it is tightened with the help of these nuts. Got it? So that the connection is complete. Understood? ठीक है.
Yes, sir.
Then the high strength bolt, they are also known as high strength friction grip bolt. So ये जो है FG, FG is known as friction grip, friction grip, high strength friction grip bolts. The grades are, as the name suggests, the grades of these HSFG bolts are ranging from 8.8 to 10.9. They are extremely efficient connections and perform well under fluctuating or fatigue load conditions. The washers are usually tapered when used on rolled steel sections. The tension in the bolt ensures that no slip takes place under working conditions, and so the load transmission from plate to the bolt is through friction and not by bearing. So there is no such connection between the plate and the bolt. So you can see over here, there may be a chance that under the loading, the plates may get in contact with the bolts and the bearing action may take place. Okay, so such kind of uh, possibility. 1 minute, hold on. लो, माझा क्लास सुरू आहे, मी थोड्या वेळाने कॉल करतो. Right. So this chance is very rare in case of high strength friction grip bolt, because the maximum capacity is taken care by that friction action. The load transfer mechanism is through friction and not through bearing. But sometimes there may be a case that under ultimate load, the friction may be overcome, leading to slip, and so bearing will govern the design. Right? So there are chances. We cannot, deny that the load cannot go beyond a specific limit. It may cross that limit, and when it crosses the limit, that is when the complete frictional resistance is taken care of by that load, then it enters into the bearing action. Bearing action, as I have told you, that the plate body and the body of the bolt, when they will come in contact with each other, then the load will be transferred through the force which is exerted by these two different materials. Okay? So fine. What are the different classification? देखो classification क्या होता है? It is nothing but the behavior. ठीक है? So that behavior we need to understand. Similarly, what are the different classifications of bolted connections? The classification type 1 is based on the resultant force which is transferred. So over here, can you see this connection? In this connection, horizontal beam is connected with these diagonal members. Okay? Above and below. So you can consider this to be bracings, right? These are bracings. Now just observe, you must have observed one thing, that this connection is being done with the help of one more component. Can you see this? Additional plate or
Yes.
over here. You must be aware of this plate, or this is new to you. What this plate may be? Actually, this is known as gusset plate. Forgive me, I don't have the pen. This is gusset. 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 Got it? Guss. ये E है, हाँ? ET. Gusset plate. Purpose of the gusset plate is to provide the complete connection of two or more members. So you can see there are three members, those are getting connected at one particular joint. So it makes a joint. Okay, whenever such diagonal members are to be provided. In those cases, gusset plates, they are very, very useful. Got it? So over here, what do you see? Based on the type of resultant force which is getting transferred, the bolts are classified. This is first type of classification. Over here, what do you observe? That the forces, as you can see, they are assumed to be passing through the centered of the connections. And what do you observe? That all the forces, they are meeting at one point. So the design is made in that order so that the forces, whatever forces the members may carry or may experience, they will meet at one particular point. That condition is known as concentric condition. And therefore, such type of connections, they are known as concentric connections. Okay? Second type of connections, they are known as moment connections. So what do you observe over here in case of moment connections? That the force is perpendicular to the connection direction. See, you can see the connections are made over here. This is the side view of, let's say, this figure. So connections are made in this direction, and the force which is applied, it is in perpendicular direction. And similarly for this. So because of that perpendicular distance, you will find additional forces develop, which is in the form of moment. So these are known as moment connections. Then second, based on the type of force experienced by the bolts. So you can say over here the bolts are experiencing certain type of force. However, when there are typical connections wherein the bolts, they are under major forces, based on that the classification is also carried out. So what are the different types? First is known as the lap connection, and second is known as the butt connection. In case of lap connection, you can see this plate and this second plate, they are forming a lap type of joint. Okay. So over here, the bolts may experience such type of force, and there may be a possibility that the bolts may fail, and there will be a shear failure in these two bolts. Similarly, over here, you can see these two plates are getting connected with the help of one more plate, which is connecting these two plates in this manner. So such kind of connections are known as butt connection. So this is known as single butt, this is known as double butt connection. Okay? Next is based on force transfer mechanism by the bolts. The force which is transferred by the bolts. First is the tension type of connections. So यहाँ पे देखो, this bolt and this bolt is connecting these plates. That is this one and this T member, you can say T section. And if some force is applied to this T section, what do you feel? In which direction these bolts will have the forces? In which direction these bolts will try to resist this force? The resistance which will be offered by these bolts will be in this direction. Okay? It is as simple as that. So you can say that the forces which are experienced by these bolts, they are in the form of tension force. Okay? And hence they are known as tension connections. In second case over here, what do you observe? That this is an inclined force. Okay, this being an inclined force, it will have these components, horizontal and vertical. Do you agree? Horizontal and vertical components. Okay. So how will be the behavior of these bolts which are connected over here? So what it will do? it will try to resist both these components. That is, it will try to resist the horizontal component in this manner, okay, and the vertical components in this manner. Am I right? Correct?
Yes.
So this typical case is nothing but tension plus shear type of connections. So such kind of connections are mostly there in frame connection or where you will find bracings. Okay? So such kind of bolted connections can be found, can be seen very frequently. So have you understood the classification? Very simple: concentric, moment type, lap, butt, tension, and tension plus shear. Then, what are the different uh, bolted connections based on force transfer mechanism? First is known as the bearing type connection. So over here you will understand the significance of bearing connections. Plates are in firm contact but may slip under loading until the whole surface bears against the bolt. The load transmitted from plate to bolt is therefore by bearing and the bolt is in shear. Generally क्या होता है, if the grade of the plate is, if it is low compared to the grade of the bolt, then there are chances that the failure of the plate will take place prior to the bolt. That is but natural, isn't it? Because the capacity of the bolt being high compared to the capacity of the plate, naturally the failure of the plate will take place earlier. So you can see over here the bearing stresses are developed. And why do we expect bearing stresses to be developing? Because you can see when these two plates which are connected with the help of this bolted connection, they are stressed in this manner. Let's say a point will come that this surface of the bolt, it will get in contact with the plate, and if the grade of the plate is less, then the bolt will exhibit its pressure or force on the plate surface, and the associated failure is the bearing failure. So can you see these holes which were drilled earlier? Okay, and these holes are naturally of greater diameter, of the order of plus 2 mm or so, compared to the bolt diameter. uh, uh, a condition came wherein it came in contact with the bolt surface, but the bolt being stronger, it did not fail. This plate, it failed. This is known as the bearing failure of the plate. Got it?
Yeah.
So similarly, you will experience shearing failure. Okay, right? So ये जो shearing failure वगैरह जो है, I will be explaining you in detail in the next class with few videos also. ठीक है? So over there you will understand how the shearing failure and bearing failure practically it takes place under certain experimental conditions. So I will stop here, and in the next class I will be uh, telling you about the details. ठीक है? So I will stop here. Thank you very much. You people can leave.